Let's look at something called as increasing and decreasing functions. Again, it's a classification of function. So a function is increasing, strictly increasing, decreasing, strictly decreasing, depending on the following condition. So there are 4 variations under this topic, starting off with increasing function. So basically, if you look at a graph which is either increasing or flat, what I mean is over here. So as in when we move from the left to the right. So this is how we talk about slopes, right? The slope is either increasing. In some space, it can be flat. So this was supposed to be flat actually. And thus making it not 1, 1. That is many to 1. Basically, this is many to 1. Right? When a function is flat, so it's like constant function, is it not? So if we have the graph to be flat at some point of time, it is many to 1. I hope you guys recall many to 1. That is, for a single output, there are many inputs. At least more than one. And again increasing. So it can be any combination. The flat region can be anywhere. So the funda is that if I move from x1 to x2, that is x1 being lesser than x2, the function will increase. And along the line, it can get flat also. Right? So let me put across an example. So this is an example of increasing. So the concept is quite simple. So the graph should always increase, and yes, it can also take a break and become 0. As you can see, the slope has become 0, and again it will continue to increase. Again, it need not be that it will be flat in the middle. The flatness can start from the graph can start from the flat and increase, or it can move from increasing to flat. Okay, so not an issue. So such a thing is called as increasing function. So as a definition, let I be an interval contained in the domain of the real valued function. So basically, it is made up of real inputs. Then we have function to be increasing in this interval if x1 is greater than lesser than x2 in this interval, and f of x1 can be either lesser than or equal to f of x2. That's what it means, right? The same thing, it's talking about the same thing. Now, strictly increasing. So what is the difference? In strictly, as the name tells, it always has to be increasing. There is no flat region. So graphically, it can look something like this. So if I move from left to right, the function increases. Okay, it's always going to increase. Let me cancel this. So if I move from left to right, as you can see, it's always increasing. And in the middle at 0, last time we saw that it became 0, but here it's not. Right? It is 2. The slope is 2. Slope of the tangent is 2 means that the function is increasing even at 0. So this is example of strictly increasing. It's never going to be flat. So the definition is similar. So here the condition is that f of x1 is less than f of x2. Okay, it's a similar writing. No point in reading that. So it has a special property, that is it's 1, 1 if not injective, right? As there is no flat region. Please recall what is injective 1, 1, 1 and many to 1. It's a simple concept. We are using it over here. Now decreasing function. As you guys can guess from the graph, let me not even read through. Let's see what the graph tells. So we have x1 and this is x2. x2 is on the right. F of x1 is greater than f of x2. And we can have a flat region. And so this is not 1, 1. It is many to 1. So that possibility is there. It can be decreasing in some part, flat in some part, again decreasing. So this pattern is possible. Right? Next, as a definition, f of x1 is always greater than or equal to f of x2. This possibility is there. And finally, let me not bore you guys. Strictly decreasing, it's the same pattern. So the basic idea is it's always decreasing and it cannot be flat in any region, as you can see from the graph. So as you move from left to right, the value should decrease. It should. There's no option of flat region. And so this is 1, 1 or injective for the same reason that there's no flat region. Okay. So this is your basic introduction. So my instruction to you guys is don't copy everything. So you can pretty much once you can write the definition, only one, maybe for increasing. Everything else you guys miss the definition, but write the graph and write the basic idea. Of course, the heading and then the graph and the basic idea around that. Or even only the graph is good enough. Okay, so yeah, put the heading and just draw the graph and mention everything over there. I think that'll be good enough. And one definition. Oh yeah, my bad. I forgot to show you guys decreasing function. So here we can see it's flat. And if I move from left to right, you can see it's always negative, the slope. Just have a look at the slope. And yes, visually you can see that it is decreasing. Under strictly decreasing, we have something like this. So it's not 0, by the way, it's -1. The graph is huge. As you can see, it's going to 60,000. That's why we can't see that. We can't see even this. You can notice a bit it's decreasing. And after that, it start decreasing in a rapid manner. So those are your graphs. Yeah. Please continue to copy.